Today we're going to take a look at arc lengths and circle area. What I want you to do first is write down the formulas that you see here with me. Notice the first one there on the left. It says S equals. Remember, this is the sine theta. What that means is the angle. That is our central angle. So S is our arc length. Theta is our central angle. Remember, a central angle just has a vertex at the center of the circle. And then, of course, radius, R stands for radius. So those are our different parts of our formula for arc length. And while we're writing these down, let's just put what these mean. This A means area of the circle. R, of course, stands for radius. I'll have these formulas posted at the front for you as well, but we have those down and we'll need those as we work through these examples today. Here's your first example on Delta Math, and we're going to start by talking about the arc length. What we need to recognize on that formula for arc length is it is the circumference formula. Remember, circumference equals 2 times the radius times pi. But we don't have the entire arc here, the entire circumference. All we have is an arc length. So we don't have the circumference, we just have S. So what we need to do is identify what proportion of the circle we have. Well, there's 360 degrees in a full circumference, but we, on this, according to this one, only have 144 degrees. That's 144 of the 360 degrees. So this is how we set up the proportion of our arc length. And we also know that our radius, according to the information, is 13. So we have 144 divided by 360 times 2 times 13 pi. Now it's very important that you look at these, that you ask answer what's being asked. This one does not ask us to leave it in terms of pi. So we will put all of this information into our calculator. Remember, you can use the alpha F1 to set up fractions. But once we put all of this in our calculator, our arc length is approximately 32.67. So as we take a look at this one, we have a circle N with a central angle of 120 degrees. Now this one gives us the arc length, not the radius, and we're asked to find the length of the radius. It doesn't specifically say radius, but it says NO, and NO is a radius. We still use the same formula, the formula being S equals our central angle divided by 360 times 2 times the radius times pi. So the parts we have this time, and notice this one is written in terms of pi. That does us a huge favor, actually, because when we divide, we're going to have to divide by pi. We know that the central angle is 120. That's 120 of the 360 degrees times 2. And I'm going to use, this is called the commutative property here, and I'm going to move the radius to the back, actually. So we're looking at this question. At this point, a lot of different ways we can solve this one because it's different values here, but this is 1/3 times 2 times pi times radius equals 6 pi. At this point, we can divide by everything we could divide by 1/3, which is the same thing as multiplying times 3, by the way. Just remember, if you do put it in your calculator this way, make sure that you use that Alpha F1 app to do this. Another way we could have done this is we could have done the 2/3 times 1. 1/3 times 2. And this would have given us 6 pi equals 2/3 pi times radius. Or we could have multiplied by 3. A lot of different ways we could do this. But I like this way because I want to talk about something I want to start getting in the habit of doing. The way I get rid of a fraction is I multiply times its reciprocal. But I would also like to get rid of the pi. So we will divide by pi here in just a moment. So here's what we end up with. We have 18/2 pi equals pi times the radius. 18/2 is 9 pi equals pi times the radius. So at this point, we are going to divide by pi, and we recognize that the radius is 9. You do not have to do it exactly how I did it there. You might have a way that you're more comfortable, maybe a shorter way. There's definitely a shorter way you could do those, but that's how we do it. So let's identify what we have and what we're looking for on this one. It tells me that UV has a measure of 7. So that's 7. And arc has, the arc VW is 7/9 pi. And this one is asking for our central angle, VUW. The formula is still the same. The arc length, in this case that's 7/9 pi, equals our central angle, which we don't know in this case, over 360 times 2 times the radius, which in this case is 7 times pi. So what we do now is we can simplify everything that does simplify. What you can also do, by the way, this is not a terrible practice, is just go ahead and eliminate these pi's. We have a pi on either side, so we essentially can divide by pi, and then we're no longer dealing with any type of pi situation. So 7/9 equals x over 360. And then we're going to go ahead and do the second math as well, which says 2 times 7, which is 14, of course. So I'm going to divide both sides by 14, or I can multiply times 1/14. That is the same thing. So whichever way you want to write it, that's fine. I chose to do the 1/14 because the other side was a fraction, so it just seemed good sense to me. 1 times 7 is 7, 9 times 14 is 126. So now we have x over 360. Seven sixteenths actually might reduce here, but it really doesn't matter. I'm going to let my calculator do the work here. So I'm going to multiply both sides times 360. This would eliminate our denominator over here. So when we do this, we learn that x equals, and remember x is our central angle, but x equals 20 degrees. So as we look at this one, you notice we do not have a diagram. If you want to draw a diagram, you can. We really don't need this information. We're talking about area now, and the area of a triangle, or circle, excuse me, is equal to radius squared times pi. Now, if you were taught pi r squared, that's fine. The reason why I'm writing them these ways is because if we're asked to leave these in terms of pi, it's already set up the way we want it to look. So we obviously are looking for our area, so that's the A value. So in order to do this, we need the radius. Well, all they've given us is the diameter. Remember, the diameter is equal to 2 radii. So if our diameter is 13, our radius is half of that amount, 6.5. So we have, we're searching for the area of a circle that has a radius of 6.5. All we have to do is plug this information into our formula. The area equals the radius, 6.5, squared times pi. Now this one does not tell me to leave it in terms of pi, but if they did tell me to leave it in terms of pi, that would be my solution. 42.25 pi. Since they wanted this answer rounded to the nearest tens, when I put this into my calculator, it's 132.7. It's actually 0.73228, so on and so forth. So this is not a equal, it is an approximation sign. So it is approximately 132.7 meters squared. Remember, we are doing area, and area is measured in square units. That doesn't mean you square the number. What that's doing is it's letting you know this is how we are measuring this. This is not a straight line. That is our unit of measurement. Please don't try to take, when we do volume, when we do area, that is just a description of how we measure things, and we measure it in square units, not in linear. As we look at this one, you'll notice it's really the same question, except we are asked to answer for area in terms of pi. So if you did it the way I did the last one, then you should be in good shape, because all we do, it's really one step shorter. Writing in terms of pi, pi is not a variable, but when we do this, we treat it like a variable. So if the diameter is 18, the radius is 9. We go to our area formula, which is radius squared times pi. We just learned that our radius was 9, so it's 9 squared times pi is equal our area. And this is why I decide to put the pi in the back, because now we're just done. This is 81 pi. Now, we are measuring in feet, so it's feet. And we are measuring area, so it's feet squared. And again, that has nothing to do with the 81 pi. That is just a description of how we are measuring. It's not a mathematical operation. It is a description of how how it's being measured. All right, the last little section here. We're going to do some circumference, and we're going to do some area. We're going to figure out how we can convert from one to the other. Now, if you need to draw a shape, you go ahead and draw yourself a shape. We're dealing with a circle here, and it tells me that it has a circumference of 121, or excuse me, it has an area of 121 pi feet squared. Area of a circle is, an area is any shape is the area inside of here that we're talking about. And the reason why we're talking about in square units, because it's two-dimensional. It's two-dimensional. Later on, we'll start talking about volume, and volume is three-dimensional. So that's what we have. So we are told that we have a triangle or a circle that measures 121 pi feet squared. So this thing is left in terms of pi. That works out really well for us because our formula says radius squared times pi. We are looking for circumference. and we want to leave this in terms of pi. Well, the first thing we need to do is figure out what the radius is. We know that our area is 121 pi units. We don't know what the radius is, and we do know that this is pi. So we've got pi on either side, so we're going to divide both sides by pi. So we end up with 121 equals the radius squared. And to get the radius by itself, we have to square root both sides. Now, just like our last lesson, we know how to take a radius and turn it into a circumference. This is plus or minus 11, but there's no such thing as a negative radius, so it is just 11. But it didn't ask me for what the radius was, it asked me for what the circumference was. So the circumference, if you recall, is 2 times the radius times pi. So 22 times 11, or 2 times 11 is 22. So the circumference equals 22 pi. The area of a circle should always be bigger than the circumference unless the circle is less than 1 in radius. And this is considerably smaller, as you can see. All right, now we're looking at our last example. Same strategy, it's just a complete opposite. We are going to go from the circumference to the area. So there are formulas. They tell us that our circumference is 11 pi, so we're going to replace circumference with 11 pi. Now, if this did not have pi values, we would still do the operations the same way. We would have to divide by pi on the other side to get this by itself. And you can't do that in your head, obviously, but your calculator can. So we're trying to figure out what the radius is, so we need to divide by everything that's not the radius. So everything that's not the radius is 2 pi. So we divide both sides by 2 pi. Thing that's nice is the pi's cancel one another, and 11 divided by 2 is 5.5. So our radius, because on the right side the 2's canceled and the pi's canceled, so our radius is 5.5. So we do not have our area, but we now have our radius of 5.5. Now I'm going to read my instructions. It says express your answer in terms of pi. Well, this works out really well because 5.5 squared is 30.25. And notice I don't have an approximation sign here because that's what it actually is. And it told me to leave in terms of pi, so my answer is the area equals 30.25 pi. Our unit of measurement was inches. I'm going to do this in another color just to make sure that you guys understand. The unit of measurement kind of stands alone here. It's inches squared. It is not a mathematical operation. It is just describing how this particular thing is being measured, and it's being measured in inches. And since it's area, it's square inches. Right, you have your Delta Math assignment there. Just be careful to be aware of your pi values. Don't let them slide away from you. And then make sure that you're answering in the correct form, whether it's rounded answer or an exact answer. Good luck.